Hi, good afternoon everyone. Today I'm going to introduce you this paper for a metaverse-based teaching building evacuation training system with deep reinforcement learning. This paper is originated by Jin Gu and the team. Okay. So first I want to start talking about the motivation of this project first. Every time if there is any emergency event like earthquake, a fire, or a flood, people will try to really in rush escape out of the building, right? They may be really panicking, they might step on each other, or they might run to somewhere that they found out that is some obstacle that fall down and they cannot pass that way, so they have to go back, or they might go to that way and they found that exit is really crowded and they cannot reach through. They might step on each other. It might cause some accident or sometimes can even cause a life. So this project is trying to maximize the benefit of those IoT device that we have nowadays, like a video camera, a smoke sensor. So we can actually see how people distribute, where are they heading to, is there any obstacle. If that way is unsafe or not an efficient exit, we can lead people to go to somewhere else that more benefit. And then I want to talk about a problem overview of the method that we have nowadays first. The current method that we have nowadays is kind of a lack of efficiency and cannot really adaptable. For example, a static sign that we follow, you can follow it, but it might lead to some unsafe environment or crowded exit, like I already said. Or the new one that is the robot lead evacuation. It's actually kind of big, right? So sometimes it can block a way of people. It can actually fall and it can cause the congestion, and it's also hard to adapt it to the changed environment. So in this paper, we changed it to be the thing called the dynamic guidance sign. The dynamic guidance sign basically is the sign on the wall, and it can change the way to go to the left or to go to the right. And in this paper, we propose the solution of reusing the thing called reinforcement learning, which is one of the machine learning. The concept of it is that we're gonna have the agent. The agent gonna have the input the state, the scene image that we capture from the camera. It's a 3D, right? And then we convert it to the 2D picture, and the agent learn from it, and then it choose the action whether to guide people to go to the left or to go to the right. And then after it action, it sees the changing environment. Whether is it good, if it good, it means that people can go to the better exit way, reduce the time, it's have the plus reward. But if it's not good, it's have the minus reward. And then keep learning and learning, it will choose the positive reward as possible. And to be able to use this, we need to have a data, and we need to make sure that it is actually okay. In this paper, they simplify the C called the metaverse. The metaverse in here, we use it to test that it is okay, and we use it to change the data before we actually use it in the real life. So we make sure that this doesn't have any negative impact to find the optimal planning. Let's see the experimental design of this. We have the experimental design. The first one is this the teaching building at the university system. We have 5 classrooms, 3 corridors, and 2 exits left and right. And then we have 120 people in here. And to make sure that it actually works, they also simplify a more complex scenario with 3 exits and 15 classroom and only 2. Let's see the result from the first one. Okay, at the initial stage, you can see that people mostly at the left side of the building. So as soon as the emergency event happened, the arrow will point to the nearest exit as possible. So you can see that in this area is pointing to the first exit 1. After a while, the agent learned that okay, exit 1 is really crowded. So if you go to the exit 1, you won't get a better reward. So over there, it changed the sign. If you are in that area, you should go to the exit 2 instead. Okay, so you can see that some people already go to the exit 2. At 80 seconds, it still think that okay, at exit 1 still really crowded. So if you're in this area, go to the right, and then At the 122nd, when most people already escaped out of the building, so it changed the side back like, okay, if you are in this area, you should go to the exit 1 because it's shorter, escape the better reward. And at this second scenario, with this more complex scene, they have like exit 1, 2, and 3. At first, at the initial state, the sign will point to the nearest exit as possible. So you can see from the circle, people in this area have to go to exit 1, in this have to go to exit 2, and in this have to go to exit 3. And from this you can see that many people is in the upper part. So as soon as the start, people will go to this part, but then the agent learned that okay, exit 3 doesn't have a lot of people go. So if you are in this bottom part, maybe you should go to exit 3. This should be faster, and then they decrease the area of exit 1 and 2. And after 122nd, it think that okay, maybe exit 3 is really crowded already. So if you are in this left side, you should go to exit 2 is better. And then yes, at the 202nd, you can see that most people already escaped out of the building already, and we have about almost equal amount of people in there, so it's indicate that it's pretty efficiency. And to make sure that's okay, they compare the result between the popular method one, like the static guided side, and then the shortest path algorithm with the reinforcement learning, which in here we use the method called the rainbow DQN or rainbow DQ network. You can see that in the first scenario, it's used the escape time of 122 seconds compared to the static side, which is 155, and the shortest path is 128. So the rainbow DQN is better. And also at the second scenario, it's spent about 231 seconds compared to the static side, and the shortest path is have the less evacuation time. And it also have a better reward. After about like 2,000 iteration, you can see that the reward in here is have like higher reward than the shortest path and the static side. So in conclusion, we can conclude that the reinforcement learning, the rainbow DQN can actually reduce the evacuation time and give a better reward compared to other popular like evacuation method. And the author also said that in future work they will work on more complex scenario, like a compact floor layout, some people on the wheelchair, or maybe like some people for during the evacuation process. That is it. Thank you very much.